In this question, a wire of diameter d, length L, hangs vertically from a fixed point. So this is the wire and is hanging with a mass of m, right? And it has the original length of this wire is L, and its cross-sectional area, because it's a wire, so we can assume that its cross-sectional area is circular, and the dia of this circular region is d. Now the point is, the Young modulus of the wire is E, and you must know E is the Young modulus and equals to stress over strain. Right? The Young modulus of any material is stress over strain. And the question is, which equation is used to determine the extension x of the wire? So we need to determine the extension x. And it's primarily a derivation problem. You need to derive the formula for the extension, right? So to start with, we can say that the Young modulus E is equals to stress over strain. So to further break it down into its original form, so how can we break down stress? Stress is equals to force divided by area, right? Force per unit area, the cross-sectional area of the wire, and the force applied on the wire, divided by, see, we are talking about this wire, right? So we are only going to consider the parameters related to this wire for the Young modulus. And for strain, we have extension divided by original length. So we know the original length, which is L. We'll put the original length L, right? So 3 parameters are unknown, or primarily 2 parameters are unknown, the force applied and the area. And rest we are going to make x the subject, and we are going to get the formula for x. So let's find out what is force firstly. So the mass that is pulling the wire is having a force of, which is the gravitational force, is equals to mg, m times g, right? So this is the force. And the cross-sectional area of the wire is pi d by 2, because it's the area, d by 2 is the area whole square, so this will become pi d square over 4. Right? This is the area, cross-sectional area of the wire. Now let's substitute these values into the formula of Young modulus. So we can say that the Young modulus E is equals to force, we know the force, which is mg, divided by the area. So area is pi d square over 4. Right? So let's have some space over here so that we can work out the remaining of the formula. Divided by x, which is the extension, divided by the original length L. Right? So after simplifying this fraction, we can say that E is equals to, so this 4 will multiply with mg, and this will become 4 times mg over pi d square, right? And we can say that 4 times mg, after simplifying the fraction, we can say that 4 times mg into L divided by x into pi d square. All right, and finally, after making x as the subject, so our next task is to make x the subject. And how we are going to do that is, let's have some space over here, and so x will be equals to 4 times mgl over pi d square times E, right? So this is the formula after doing the derivation using Young modulus, the formula for Young modulus. So the correct option we can say is 4 times mgl over 4, option D, 4 times mgl over pi d square E.